In this video, I'm going to give you a brief overview of an exciting new tool from Desoutter that can enhance both your quality and production strategies in your assembly operation. The tool we're talking about today is the Desoutter DWTA Vision Wrench. And basically what this is a digital torque and angle measuring wrench. Now this wrench has a transducer and a gyro in it, which allow it to take measurements regardless of the position, whether it's horizontal, sideways, or upside down, and it's accurate to plus or minus 1%, which puts it on par with a DC electric tool. And what makes that nice is if you're using air tools in your operation and you all of a sudden have an increase in your accuracy requirement, you can go ahead and use this wrench for either final tightening or for your quality control check afterwards to verify that you are at the right torque and verify that you are within plus or minus 1% of the torque that you note for your application. So basically the way that you set this up is you're going to install the software that's included with the tool on your PC, and then you can program your strategies right on there, whatever the parameters for your application are. And this particular tool goes from 0 to 30 Newton meters, but there are 3 other variants depending on what your torque window is. So you choose the one that's most appropriate for your application. So we already have set this tool up for a couple demos, and basically we set it up with the software, and I'm going to show you 2 of the most common strategies used. The first one's going to be torque plus angle, which is common in the automotive industry. And basically what that is that strategy says you get to a specific torque value and then you want to add a number of degrees of angle on top of that to ensure that the slack is taken out of your joint. The second strategy that we're going to demonstrate is residual torque check. And that's going to check the amount of torque that's already applied to the fastener after the fact. And that's a quality control strategy to verify that everything is as it should be with your application. So for the first example, we're going to go ahead and turn the tool on and set it down and allow it to calibrate itself, which only takes a second. Once it's calibrated, the screen's going to turn green and beep, which it just did, letting me know we're good to go. And here's our bolt right here, so I'm going to get started. And again, my parameters are 35 inch-pounds plus 50 degrees of rotation. Now you can see I have the ratcheting head on here. There are also an open-ended head and a couple other heads that can be swapped out depending on what you prefer and what your application calls for. Now the screen is showing me in real time how much torque is already applied to the fastener. Once we get to 35, the neat thing is it's going to start showing me the angle as well. Here we go, there's 10 degrees, 15, 20. Now I went too far on the angle. I went to 60 degrees. So this is what happens when you go too far. The tool turns red and it lets you know something's wrong with what just happened. And this is important because if your screw is stripped out, if there's debris in there, you're going to be outside your torque window, and this tool is going to let you know right away that there's a problem with your fastener. So let's do it again. We're going to go to the correct window this time. It's 35 inch-pounds. We're measuring angle now. And there we are. So we're at 50 degrees, and it's showing me that once we reach the 50 degrees, we got 46 inch-pounds of torque on that fastener. So that's within my spec. So the screen has turned green and gave me a positive beep letting me know that we are where we're supposed to be. So that's one verification right there. Now our second strategy, residual torque check, is again, this could be used by a quality control person to come back and verify how much torque is on this fastener. And the important thing about the residual torque check method is it's a better way to check torque than a breakaway torque method, because a breakaway torque method requires you to actually loosen the fastener slightly in order to get a value of how much torque is on that fastener. The problem with that is you're introducing even just a little bit of slack into the joint, whereas with the residual torque check method, we're going in the tightening direction. And this tool can actually sense exactly when the bolt breaks away and starts moving in that tightening direction and give me the value right at that point. So what I'm going to do here is I'm going to double check and make sure we have the right amount of torque on this bolt, and it's only going to take 3 degrees of rotation in the positive direction. And again, what's good about that is if anything, we're only tightening the joint a little bit more. We are not introducing any slack into it whatsoever. So here we go. We're going to switch strategies, which is as simple as going into the menu here, selecting the second strategy, hitting OK, and now we're ready to go. And there it is. It only took 3 degrees of movement, and it verified 47 inch-pounds on that fastener. So again, it was telling me you're within the spec of your application, everything's good. If for whatever reason we were out of spec, if there was too much or too little torque, again, it would have turned red, as we showed in the first example, giving me that buzzer sound and let me know there's a problem. Now another exciting feature about this tool is these results that we're recording here are actually being stored in the tool's memory. Once I plug this back into the computer and open up the Delta QC software again, I can actually view all the results of the cycles prior to my last cycle, see the historical data, and even save that to a spreadsheet file. So I have a record of all the application information that was checked during the day to verify that we're within the spec consistently or we're having problems periodically, etc. So this is a great tool, and again, for this capability level, normally you would use a DC tool and it would cost you a lot more than this tool right here will. But this tool is going to give you the same level of accuracy. You can add it right into your air tool operation, and you can use it again for both final tightening and for quality control. So this is a nice tool, and you can read more about it on our website.